Hi guys, so last lesson we looked at neutralization and the pH scale. Today we're going to end this topic by looking at strong and weak acids. So, something to think about. Vinegar contains ethanoic acid dissolved in water. It's got quite a high concentration and you can tell because it's got such a strong smell, but if you get vinegar on your skin, for example, it doesn't burn it. Why do we think that is? Just pause the video and have a think about why that might be. Now, last lesson we said that acids must dissolve in water before they show their acidic properties. And when put in water, the molecules split up or ionize or dissociate. So we've got to get familiar with those two terms, ionize or dissociate, which basically means the molecule splits up. Now, if we look at hydrogen chloride gas, when that's dissolved in water, we form hydrochloric acid. Now, hydrochloric acid in water ionizes and releases hydrogen ions in the solution, which causes it to become acidic, and therefore it has a low pH. Now, we call hydrochloric acid a strong acid because every single molecule of hydrogen chloride in water fully ionizes. That means that every single acid molecule releases a hydrogen ion, and as a result that solution has a very high concentration of hydrogen ions and therefore a low pH. Now, if we were to test the pH of hydrochloric acid, it would be around 1. Now, we also talked about how there is a direct correlation between pH and concentration of hydrogen ions, and we said that for every increase in pH, the concentration of hydrogen ions decreases by a factor of 10, and you need to be very familiar with writing out the concentration of these hydrogen ions in standard form. Okay, so just as an example, if we have an acid with a pH of 2, that's got 10 times less hydrogen ions than an acid with a pH of 1. So what makes acids acidic? So let's go back to our vinegar example, and we're going to pair that up with hydrochloric acid. Let's say we've got 2 beakers here, the same concentration of hydrochloric acid and the same concentration of vinegar. That means concentration means the number of acid molecules per volume. Now, hydrochloric acid is a strong acid, so every single molecule will release a hydrogen ion. So if you look carefully, you can see that every single molecule of that acid split up and every single molecule released hydrogen ions. So we say that strong acids fully ionize in water. Now let's look at what happens with the vinegar. If you look closely, you'd see that actually very few of those molecules ionized or split up. And actually most of them didn't split up, nothing happened. And actually that is where we get our definition of a weak acid, that it only partially ionizes. It does not fully split up. The molecules do not fully split up, and not every molecule will release a hydrogen ion. And therefore this explains why strong acids have a high concentration of hydrogen ions, making them very acidic, whereas weak acids have a lower concentration of hydrogen ions. They're still acids, but weak acids, not very strong acids. So just to emphasize that point, strong acids on the left here that you can see, let's say that those red dots, they represent hydrogen ions. We can see that for every single molecule a hydrogen ion has been released, and therefore that substance would be a strong acid, whereas on the right only some molecules have been dissociated or ionized, and therefore that would be a weak acid with a much higher pH than the stronger acid. So once again, let's just write this equation out. So this is obviously the dissociation of hydrochloric acid in water. We know that in order to form hydrochloric acid, we have hydrogen chloride gas dissolved in water, and every single molecule releases a hydrogen ion. So all acid molecules in strong acids, not just hydrochloric acid, but all strong acids release hydrogen ions. Now the new acid for us, this is ethanoic acid. So let's just get quite familiar here with its formula, CH3COOH, so that's ethanoic acid. Now there's also a new symbol here, one that we're not familiar with. This symbol here, these arrows, if I just circle them, that is the symbol of what we call a reversible reaction. We've got a whole topic coming up that talks about reversible reactions, but in weak acids, the molecules, only some of them will release a hydrogen ion. Now this reaction is reversible, so what that means is that actually some of these ions that have been split up, they could actually rejoin together and recombine and form acid molecules again. And what that does is it shifts this equilibrium to the left, which means that we've got even fewer hydrogen ions in our solution. Okay, so this symbol here is for a reversible reaction, which is basically a reaction that can go in the forward direction and the reverse reaction, and it means that the products can recombine and form this molecule again. Okay, that is what a reversible reaction is. But the idea is that in a weak acid there are significantly fewer hydrogen ions. Now let's look at some examples of strong and weak acids. So let's look at ethanoic acid. If we use universal indicator, the colour would be orange, and that would indicate a pH of about 3, and that is a weak acid. Nitric acid, however, would show up red. We'd give that pH of about 1, and therefore a very strong acid. Citric acid, deep orange, pH of 3, very weak acid. Citric acid is found in a lot of citrus fruits and things like lemons and oranges. Carbonic acid, very light orange, pH of 4, again another weak acid. Hydrochloric acid, a strong acid, we know this one's going to have a pH of about 1. Sulfuric acid, quite strong acid, once again a pH of 1. So guys, it's not just hydrochloric acid that's the strong acid. You need to be familiar with our strong and weak acids, so just make that really clear in your notes, which acids are strong and weak, and now we understand why they are strong and weak. Okay, could you just pause the video and fill in the gaps on these sentences, just summarize what we've done. Okay, strong acids have a low pH. Strong acids have a high concentration of hydrogen ions because they fully, or you could have said completely, ionize. Weak acids have a higher pH. They have a low concentration of hydrogen ions because they partially ionize. Okay, so that, guys, is your definition of a strong and weak acid that you need to know. Right, what about concentrated acids? What is the difference between the strength or weakness of the acid and the concentration? Okay, now really important, guys, that we remember that the definition of concentration is the number of molecules in a given volume. Now I've got here hydrochloric acid and ethanoic acid in my conical flasks. Now I can tell that they are the same concentration because they both read 0.1 molar solutions. But what I know from my table earlier is that hydrochloric acid is a strong acid, but ethanoic acid is a weak acid. Now they are the same concentration, but hydrochloric acid is strong and ethanoic acid is weak. Okay, and we know why they're strong and weak acids, but just be careful not to mix up the term strong with concentrated. Okay, now let's say I was to take my hydrochloric acid, okay, and I wanted to dilute the solution. We're now going to look at what happens to the pH if I dilute this strong acid. Okay, I want you to look at this table and I want you to think about what is the link between the concentration of hydrogen ions and pH. Okay, so it says, looking at the concentration of hydrogen ions, if you take the minus value of the power to which 10 is raised, it gives you the pH of the solution. So if our concentration of hydrogen ions in solution, so remember moles per decimeter cubed is a unit for concentration. In this case we're looking at just the concentration of hydrogen ions in our solution. So if the concentration is 1 times 10 to the power of minus x, then x will be the pH of that solution. Now, if you notice that the trend going down, and going down, so each time the pH is increasing by a factor of 1, but the concentration is decreasing by a factor of 10. So in other words, if you dilute the acid by a factor of 10, or if you dilute that solution 10 times, the pH increases by 1. Okay, so this is just written out in standard form, and it shows quite a nice way to remember actually. So here we've got 1 times 10 to the power of minus 1, that minus power, if I follow my rule, 1 times 10 to the power of minus x, x is 1 here, so my pH is 1. Now, just careful that each time the concentration increases by a factor of 10. So if my solution here has a pH of 1, this solution here has got 10 times less hydrogen ions. But if my solution has a pH of 3, it's going to have 10 times 10 fewer hydrogen ions, so that would be 100 times less. And then if I've got a pH of 4, then I've got 10 times 10 times 10 fewer hydrogen ions, so that's 1,000 times less the concentration of hydrogen ions. Right, if you pause the video and give yourself, once again, let's try about 10 minutes to have a go at these questions. Just pause the video and have a go. And let's quickly go through them. Question 1 says equal amounts of sodium carbonate are added to the beakers. So we've got the same volume of sodium carbonate containing, they're added to beakers containing ethanoic acid and dilute nitric acid of equal concentration. What's the difference seen? So if you remember this reaction from video 1, we learned about the different reactions with acids. This one will produce carbon dioxide gas because we've got a carbonate, a metal carbonate, and you're going to see lots of fizzing, but because ethanoic acid is a weaker acid, it will be a much slower reaction and less gas will be given off in the same time. Right, next question. What is the pH of a solution with 1 times 10 to the minus 5 moles per decimeter cubed solution of hydrochloric acid. So if I look at my power, it's minus 5, so following my rule, that would be a pH of 5. For question B, we had a neutral solution. So neutral solutions have a pH of 7. So this time we need to translate our pH into concentration of hydrogen ions. So that would be 1 times 10 to the minus 7 moles per decimeter cubed. The question asked for both your answer in decimals and in standard form. So you need to give yourself a mark for each of those. For question 3, we had propanoic acid and carboxylic acid. One is weak and nitric acid is strong. So what is the difference essentially between weak and strong acids is what you're describing. The idea is that because propanoic acid is weak, we know that not every molecule will fully ionize, so only some molecules ionize and release hydrogen ions. The reaction is reversible. Most of the molecules remain intact. They do not dissociate, whereas nitric acid, every single molecule of nitric acid will release hydrogen ions in water. Right, last question. Explain why it is possible to have a very dilute solution of a strong acid with a higher pH than a concentrated solution of a weak acid. Well, this comes down to, firstly, how much that strong acid was diluted by, because we know that pH is directly correlated to the concentration of hydrogen ions. Now, the more dilute we make that solution, the lower the concentration of hydrogen ions. In this case, it suggests that even though that acid was diluted, it wasn't diluted to the point where there were fewer hydrogen ions than in the weak acid. So the strong diluted acid still would have a higher, in this case, concentration of hydrogen ions than the weak acid. Okay, if you would just give yourself a score out of 4, 8, 12, and that is the end of this topic, chemical changes.